Good morning, everyone. Today's driving question is how can we revise for our end of term quiz? Just a reminder that your date and your driving question should be on the line. You should have a sheet of paper or your biology exercise book to make notes and write your answers to all the activities throughout the lesson. And finally, any other device not in use should be switched off. Just a reminder that at some point next week, I believe on the 13th, you will have a 30-mark revision quiz. It will be a multiple choice quiz, and the expectation is that you complete the quiz and submit it before the deadline. So that is next week. Right. We're going to begin our revision lesson. This is a remember task. And what I want you to do is to brainstorm your ideas. So what do you know about energy? So in your exercise book, you're going to draw out this bubble right in the center of it. What do you know about energy? And brainstorm all your ideas and write it down on a sheet of paper or in your exercise book. I'm now going to ask you to pause the recording. Right, welcome back. So energy stores. Do you know the different types of energy stores? Can you give some examples of each? Energy and exercise. What is the relationship between energy and exercise? Why is it important? What happens? Energy transfers. How does energy transfer from one energy store to another? Energy generation. How is electricity generated? Are there any future developments that aid to reduce energy costs in the long run? Energy in the news? So these are different ideas that you could have listed, and we're going to be getting into more in depth about each of the following topics here throughout this lesson. So let's begin. So your first task is to define the following keywords. You're going to write the word out and then you're going to define each of the following keywords. And these keywords will definitely show up on your end of term quiz next week. You can now pause the recording. Right, calorie. So the amount of energy in an item of food or drink is measured in calories, okay? Give yourself a tick if you got that right. Efficiency is a measure of how good a device is at changing energy from one form to another. Dissipated energy is the wasted energy, because energy can be wasted into these surroundings. Global warming is a gradual increase in the overall temperature of the Earth's atmosphere. And lastly, renewable resources is a resource that can be reused again and again. It does not run out and it can be naturally replaced. So these are a few keywords that you definitely need to know for your quiz next week. Right, let's move on to the next activity. Write T for true and F for false in your exercise book for each of the following statements. Again, you do not need to rewrite the question, only the answers. At this point, I'm going to ask you to pause the recording to write your answers down. Right, welcome back. Question number 1. Energy cannot be created or destroyed. That is true. Question number 2. Energy cannot be transferred from one energy store to another. That is false. Energy can be transferred from one energy store to another. Number 3. Efficiency is a measure of how good a device is at changing energy from one form to another. That is also true. Number 4. The more efficient a device is, the more energy is wasted. That is false. The more efficient a device is, less energy is wasted. Question number 5. Wasted energy spreads out into the surroundings, and this is called dissipated energy. That is also true. And lastly, this dissipated energy is too spread out to do useful work and cannot be reused. That is also true. So this is just a recap from your previous lessons from the entire term. Now let's move on to the next activity. Right. The instruction says to match the image to the correct energy store. So you've got your burger, nice and juicy burger here. You've got your the cheetah running. You've got rubber bands, and you've got someone here skydiving. So you're going to match all the images to the correct energy store. At this point, I'm going to ask you to pause the recording to see how much you remember. And write your answers down in your exercise book. Right, welcome back. So the nice juicy burger is going to be chemical energy store. The second one, movement. Organisms that move or anything that's moving has kinetic energy store. Rubber bands will be an example of elastic energy store. And lastly, it's going to be gravitational potential energy store. So again, a recap on your energy stores from the term. Let's move on to task number 4. Right. We know that energy cannot be created or destroyed, but it can be transferred from one store to another. The task says to use the image to explain the energy transfer. So here you go. There's your filament light bulb. You have to explain the energy transfer. What energy did we start with? You're going to put it in this bubble. And what energy is going to be transferred? So it's going to start with one type of energy stored and transfer into another type of energy store. So I'm going to ask you to pause the video, think, and write your examples down this way to show the energy transfer. Right, welcome back. So you've got electric, as you can see, filament light bulb. That's going to, electric energy is going to be transferred to heat and light. So this is an example of energy store that you should be aware of for your end of term quiz next week. Right, task 5. Use your knowledge about energy to explain what the images shows. I'm going to show you an example of the first food chain. So here you've got the big, beautiful sun that is star. And then you've got your plant here, your corn, you've got a chicken, and then you've got me and my baby. Okay, what is happening in the food chain? How many things can you tell me about this food chain? I want you to pause the recording and then write your thoughts down. Right, welcome back. So you could have said that the sun is going to release solar energy. That solar energy is going to be stored in the plant as chemical energy store. The chicken is going to eat the corn plant and store that chemical energy as chemical energy store. I am going to eat the chicken and also store the energy as chemical energy store. So to summarize, the arrows in the food chain shows the energy transfer from the one organism to another. We know that food chains begin with a producers, and producers are plants that manufacture their own food. The chicken will be an example of a herbivore because herbivores eat plant-based foods only. My baby and I will be an example of omnivores because we eat both plants and animals. However, if I were to substitute my photo with, for example, an organism, let's say an alligator that eats meat only, that's going to eat the chicken, then the alligator would be an example of a carnivore. So organisms that eat plant-based food only are omnivore, and organisms that eat both plants and animals are known as omnivores. If you eat meat only, you'll be known as a carnivore. So these are the different things you can say that's occurring in the food chain. You need to know what the arrows show, the definition of a herbivore, a carnivore, an omnivore, and the type of energy released by the sun. Okay? And another example here that you can explain. I would like you to pause the recording and try to explain what's going on with the jerk chicken and this image here. What is it showing? And that image to connect the pictures to form a story. So it's a good Pictionary activity. You can now pause the recording and have a go. Right, as you can see here, you've got your nice jerk chicken that you've created just at the beginning of the term. You're going to start eating that chicken, crushing it with your teeth. So mechanical digestion is occurring there. That food will be, will move down the esophagus by a process known as peristalsis. It will go to the stomach, and then the large intestine and small intestine. And then after digestion, it passes through the rectum and anus. So you should have been saying chemical energy is going to be um, obtained from the eating the chicken. You should have mentioned the digestive system is the example of the organ system that's going to break down food into smaller nutrients so that it can be absorbed by the bloodstream. And lastly, we're going to get energy from that food that we eat to do all the different activities you can see here. Stretching, eating, brushing our teeth, getting dressed, going to work. What you need to understand is energy is used even when you are asleep, but only a small amount of energy is used. So, based on the activity, the amount of energy that's used will vary. Right, task number 6. Use your knowledge about energy to explain the relationship between energy and exercise. Here, this is what I do every day, just playing. Well, what you need to understand is how this energy relates to exercise. You are doing all the exercises, your footwork here, you're doing your pull-ups, your jumping jacks, your push-ups. How can you relate energy to exercise? Okay, how can you relate energy to exercise? Okay, so what you need to know is that during exercise, the body needs more energy to perform tasks. Your heart rate is going to increase. Your breathing rate is going to increase. The rate of oxygenated blood being delivered to your muscle cells will also increase. Therefore, aerobic respiration will also increase. Okay? During vigorous exercise as well, you need to remember that you can suffer from muscle fatigue, and this is caused by the buildup of lactic acid in the muscles where oxygen is not present. So these are the different things you could have said about energy and exercise. More energy is needed during exercise for us to perform a variety of tasks. Task number 7, give examples of renewable resources and non-renewable resources. It's very important, just at the beginning of this PowerPoint, that you know the difference between the two, okay? Renewable resources can be replaced over time. Naturally, they can be used over and over again. Obviously, non-renewable resources are the opposite. So give some examples of renewable and non-renewable resources. You can now pause the recording. Right, welcome back. So here is your chart. So examples of renewable resources: solar, wind, hydropower, geothermal, biomass. If you're still unsure about these examples, you can go back to Mr. Samuel's presentation. Some examples of non-renewable resources will be oil, gas, coal. So these are examples of renewable and non-renewable sources that you need to know for your 30 mark multiple choice quiz next week. Right, task 8. Use the image to explain how a power station works. You can click on the video, you can watch the video, or you can try to make some notes by following the image. Okay? So how does a power station work? Now I'm going to ask you to pause the recording and write your thoughts down. Right. So as you can see here, Oops, don't know where that's going. As you can see here, you have present. What you could have said here is that you have here you've got the boiler, you've got fuel here, for example, coal, which is a non-renewable resource. Coal is going to be burnt, and that burning of coal will produce, as you can see here, heat and steam, and it's going to allow water to boil, and that steam here is going to start being produced. The steam being produced here will be able to push the steam turbine, and the steam turbine will then activate wires in a generator to therefore produce the electricity in your house. So it kind of starts from the burning of fuel here, for example, coal, and that burning of the fuel is going to produce that heat that's going to allow water to start to boil and produce steam. That steam that's produced turns the turbine, and the turning of the turbine also turns wires in the generator to produce electricity in your home. So just a visual aid to kind of remind you of how a power station really works. Right. Task number 9, very important. When you see the word critically evaluate the use of coal to generate electricity, this word here, the words critically evaluate means give me the good thing. Give me a good thing about using coal to generate electricity, or a good thing, or a pro, or an advantage of using coal to generate electricity. On the other hand, when you evaluate, it means give me a bad thing, give me a con, give me a disadvantage of using coal to produce electricity. So you need to look at the good and the bad when you see the word evaluate. So I would like you to evaluate the use of coal to generate electricity. So what I'm going to ask you to do is pause the recording and write your thoughts down. Right, welcome back. So the pros, the good, or the advantages versus the cons, the bad, or the disadvantages. So you could have said it's usually cheaper than renewable energy. You could also say that non-renewable resources such as oil and coal can be stored and used when you need it, okay? So that you can store it and it can be used when you need it. So those are like the good things that you could have said. On the other hand, the bad thing you could say is that the burning of coal increases carbon dioxide in the air, which is going to pollute the atmosphere, contribute to the greenhouse effect and global warming. And you can also say that supplies are running out and new resources are harder to get, okay? So we can say that, for example, oil and gas are both predicted to run out in the next 100 years, okay? So non-renewable resources, for example, coal, it's going to run out at some point. So we need to find different ways of generating electricity in the long run. So just remember, when you critically evaluate, all it means is the pros versus the cons. Okay? Right. You will also need to know how to calculate energy efficiency. So energy efficiency is equal to the useful output energy divided by the total input energy. So your first example is this filament light bulb, oops, is supplied with 100 joules of electrical energy, which it converts to 45 joules of light energy. Okay, so you've got the output there and the input. It says calculate the energy efficiency of the bulb. Your answer will be 45%. You can look at the previous presentations if you're struggling with energy efficiency. Is the useful output energy divided by the total input energy. So the useful output would be 45 and the total input will be 100 joules. So if you divide 45 by 100, you will get 45 percent, because you have to times the answer by 100 to calculate the percentage. Energy transfer. This is another equation you will need to know for your exam. The energy transfer is in joules, as you can see in joules. And the energy transfer is power, which is in watts, times the time, which is in seconds. So, a 2000 watt kettle boils in 150 seconds. Calculate the energy transferred. I would like you to pause the recording, use the equation to calculate the energy transferred. Right. The energy transferred will be 2000, which is the power in watts, times 150 seconds, times the time, and that will give you 300,000 joules. Energy transfer can also be in kilowatts per hour. That would be power, which is in kilowatts, times time in an hour. So Andrea uses a 3 kilowatt heater for 4 hours to heat her house on a cold day. Calculate the energy transferred. Okay, I would like you to pause the recording, use the equation to calculate the energy transferred. Right, welcome back. So the energy transferred will be 3, which is the kilowatts, which is the power, times the time, which is 4 hours. So the energy transfer would be 12 kilowatt per hour. So as you can see, energy transfer can be in kilowatt per hour, or it can also be in joules. So it depends on which equation is given to you. We can also calculate cost. So you would have to take the energy transferred, whatever energy that's being transferred, whether it's in joules or in kilowatt per hour, times it the price per kilowatt per hour. So this price is going to differ based on your supplier, obviously. So here's an example. Electricity costs 16p per kilowatt per hour. At the start of the month, Lisa's electrical meter reading was that number, kilowatt hour, and at the end of the month, the reading was this number, kilowatt hour. So you have to say, if at the start of the month it was this, but at the end of the month is this, how would you find the difference? You'll have to subtract the small number from the large number. Now it says to calculate the cost of her electricity bill last month. I would like you to try to use the equation to calculate the cost of electricity. You can now pause the recording. Right, welcome back. So the energy transfer, like I said, she read the meter at this time, and at the end of the month, she read it and she got a different reading. You have to subtract both of the readings, and the answer would be 315.25 kilowatt hour. But that's the energy transferred. We now need to take the energy transferred times the price. We took the energy transferred, which is here, times the price, and we got 5,044 pence. To convert pence back into pounds, you will have to divide the number by 100 because there's 100 pence in 1 pound. Okay, and that will give you £50.44. How can you modify your home to reduce energy costs? So you can also be tested about different home modifications on your quiz next week. Okay, so different ways you can modify your home is by using insulating your walls. Make sure you know what an insulator is for your exam. Solar panels on the roof, and for example, double or triple glazing windows. So these are a few examples that you can do with your home to reduce the energy cost in the future. Now, you also need to know how famous people has helped us to either discover electricity or make improvements with electricity. So, what did Benjamin Franklin do and what did Thomas Edison do? Okay, so these are the two famous people that you need to know for your quiz next week. So I would like you to pause the recording and try to remember, what did Benjamin Franklin do? What did Thomas Edison do? Right, welcome back. So Benjamin Franklin did the kite experiment with the Leyden jar, and he kind of reintroduced electricity back to the public. Okay, and Thomas Edison was the man or the scientist that created the first light bulb. So these are the contributions that you need to know about. Don't break the chain. Whatever you do, you're going to answer these sequence of questions, but don't break the chain. Give examples of greenhouse gases. What is the main cause of global warming? And explain two effects of global warming. So, if you give examples of greenhouse gases, you are only going to get silver. But if you can tell me what is the main cause of global warming, that takes you to gold. And if you can tell me or explain two effects of global warming, then you're going to get a diamond. So try to answer these questions from the top of your head. Good retrieval practice. No looking back at notes. Pause the recording. Go. Right. Welcome back. Your greenhouse gases could be carbon dioxide, for example, methane. It could be nitrous oxide. Also, number 2 is human activities. That's the main cause. And number 3, I know the answers are a bit jumbled here. I should have made some more space. And lastly, you could have said rise in sea levels, ice caps melting, ice caps in the Arctic melting. The distribution of species can be affected, and also migration patterns. It is very important that you have general knowledge on energy in the media. Recent knowledge, for example, the impact that the lockdown had on the climate, England's cold-free period, technological improvements that aid to save energy, and for example, disadvantages of electricity, for example, blackouts and electrocution. So you need to know basic ideas of the 4 following points. Okay? Lastly, you're going to complete the self-assessment quiz on Google Classroom. This self-assessment quiz is basically a yes or no answer. If you answer no, this means that you will have to now make flashcards or a mind map based on the area of weakness. The questions that you answered yes to, it means that you are 100% confident of your answer and you know the topic in depth. If you've answered no, then you will have to create flashcards. So you're going to tick yes or no and submit your quiz at the end on Google Classroom. The self-assessment quiz needs to be completed. Okay, you need to be focusing and showing that you have no other forms of distraction there to distract you. And like I said, all the questions you've answered no to, you will need to make a flashcard. Flashcards are mind maps to enhance those or amend those gaps in knowledge. This is going to help you for your 30-mark multiple choice end of term quiz on Monday, the 13th of July. Again, this is Miss Burnett, and stay safe.